At 1821, London, the world's greatest physicists were stuck. They knew electricity could shock, spark, and glow. But could it move? Could it push an object in a perfect circle, endlessly? Like a tiny, invisible hand. Every scholar said no. And then, a quiet bookbinder's apprentice walked into the story. With no money, no degrees, and almost no math, and proved them all wrong. Early 19th century London was loud, smoky, and powered by horses, steam engines, and muscle. Electricity was a scientific toy, strange, dangerous, and mostly useless. The scientific elite were obsessed with one question: what is the relationship between electricity and magnetism? Hans Christian Ørsted had just shown in 1820 that an electric current could deflect a compass needle, a miracle, but no one knew what it meant. Academics argued, journals filled with equations, but real progress, zero. Enter Michael Faraday, born into poverty, educated to the level of a 12-year-old, binding books for a living, yet secretly copying scientific diagrams at night, teaching himself chemistry from torn pages, and dreaming of experiments he had no equipment for. He wasn't a scholar. He wasn't qualified, but he had something most scientists didn't: a stubborn, almost childlike curiosity, and hands that loved to build things. In 1821, Faraday built a strange-looking device on a wooden table at the Royal Institution. Imagine this: a bowl of mercury, a copper wire hanging freely, a small vertical magnet standing in the middle, and a single battery delivering a steady electric current. He connected the wire, current flowed, and then, in a moment that should have been impossible, the wire began to spin nod once, not as a flicker, but in a smooth, continuous circle. A piece of metal was orbiting a magnet, motion created purely by electricity. This wasn't a magic trick. It was the first electric motor in human history. Faraday repeated the experiment dozens of times, changing the length of the wire, measuring distances in millimeters, adjusting current strength, reversing magnetic poles. Every trial confirmed the same truth: electricity and magnetism are one force, electromagnetism, and they can create continuous motion. Faraday had uncovered a law the world didn't yet have words for. A current plus a magnetic field equals motion. Today we call it electromagnetic rotation, the foundation of every motor that has ever existed. No equation, no formal training, just intuition, hands-on testing, and a fearless willingness to be wrong 99 times to get it right. Once, the scientific establishment was stunned. A bookbinder's apprentice had solved a problem. Faraday's spinning wire became the father of the electric motor, 1821, the electric generator, 1831, and the principle of electromagnetic induction, which powers every power plant on Earth, every elevator, every washing machine, every subway train, every factory, every data center, every handheld fan, even the device you're watching this video on. Tane traced back to that moment in a London lab when a piece of copper wire began to turn. Faraday didn't just make something spin, he changed the direction of civilization. When you plug in your phone, when a drone lifts into the sky, when a Tesla accelerates silently, you're watching Faraday's idea running at thousands of revolutions per minute. A boy who couldn't do calculus gave the world the ability to power cities. So here's the question Faraday leaves for us. How many breakthroughs are waiting, not in textbooks, but in the hands of people who dare to try when they're not qualified? Because sometimes the ones who change the world are the ones no one expects.